Hello, my name is João Freitas. I'm working for Deutsche Telekom as an architect in the product team. And in addition to that, I'm also chairing the Lifecycle Management Working Group alongside Chris Gray, and more recently also getting an invaluable support from Dave Chapman. I don't have such an interesting icebreaker like Carlos Santos had with the purple sky, but I'm happy to say that the working group has been evolving, and today the fact that I'm sharing this stage with other people really sends a strong message that this is not a one person, this is not a one company effort, but rather different companies coming together and really delivering something. And I think that's what we all expect to see and hear from the open source and standardizations bodies. We already had some presentations long time ago describing what we wanted today, but it's always interesting to do a little recap on our ambitions, why we are doing these things, but to also finally showcase some of the things that we've been doing, which are not always obvious to everybody. We have a lot of slides, so I apologize if not everything is going to be clear to everybody, but we can also answer the questions. You can find us around, and we will be circulating the slides. So getting started with a recap on the LCM. I mean, describing it in simple words, this is just enabling the software to be managed, the firmware to be managed as software modules. The working group has essentially three main ambitions. Enable that microservices architecture, which we are all talking about, sandboxing this service, but also start to enable these new concepts like an app store and so on, which we already see in other fields like smartphones. Why are these things important? Starting with the first point, essentially speaking, you see a big trend that we service providers, we start to put a bit more emphasis in the creating services rather than just being the pike, that connectivity. And that immediately puts us in a situation that in order to deliver these things, we need to collaborate with more and more companies. We don't see that model where it's just the service provider working with one OEM. Now you see it's the service provider, the OEM, and open source industry, different companies also providing services, security, Wi-Fi, and so on. And that creates a different way of working. What we have is essentially different teams working together, and they are working at different paces. Maybe the firmware team is trying to deliver 2 or 3 firmwares per year, but maybe we have our security company trying to do something a bit more at a faster pace, maybe trying to release security patches every 3 weeks, or the smart home proposition doing it every 3 months. And we are trying to put all this together into a firmware. And this creates some logistical problems, not just technical problems, because at the end of the day, if we are only deploying firmwares 2-3 times per year, but our partners, they want to do it a bit more often, like Ian described in an agile way, how do you resolve this conflict? Because then you have the service provider saying, no, I don't want to do it every 2 weeks, but you have also the other situation. And this is important because somebody has to test these things. Somebody has to pay for these things, and the reality is we all want to work agile, but we need the right frameworks to solve these problems. Second situation that we face is really the sandboxing problem. Applications, they have different needs, they have different dependencies. Some things are simple, they just need access to a couple of APIs. Other things need deeper access to perhaps drivers and so on. And without a proper framework to achieve these things, then you are into situations that you have to be careful with not exposing sensitive data. You have to be careful so that the integration is done in a way which is not triggering the wrong APIs, creating inconsistent states and other problems. And again, without the proper tools, this forces us into spending a lot of efforts in testing and security. And the reality is the conversation shifts from SDKs to NDAs, and that's a big difference. Another important statement still on the sandboxing is that there's value in sharing resources because there's a cost effect out there, but the reality is that sharing resources also comes with sharing its problems. So you might have your critical service very stable, very well tested, everything works, but suddenly you have something new that you need to add to the box. And maybe there's a little memory leak out there. Maybe this is causing some unresponsiveness. Maybe it's causing some crashes, some software reboots, and suddenly you're trying to add more value to the customer, but you start to introduce other problems which were not there before, and of course, this does not result into the experience that we all want to provide. Perhaps another interesting aspect is this concept of the App Store. We talk about these things because the reality is we want to differentiate, but different customers also have different needs, right? Perhaps you might have a family, you may need parental controls, maybe somebody else lives in a bigger apartment and they might need a managed solution like a Purple Mesh or something else. And all these, I wouldn't call it fragmentation, but all these different needs forces us to create a software that can adapt to different needs. And that's what we are trying to portray in this picture, that we put everything there trying to fulfill the different needs. But reality is that each customer is only using a subset of all these things. And one might say this is okay. I mean, for sure it works, but there could be also other ways of doing it, and now that we see that sustainability is also becoming an important topic, I question myself if LCM can also somehow help us with this problem statement, because the reality is if you have a customer with a couple of services that he's not using, that's extra boot time, those are extra resources that are being consumed, and with LCM, you could just say, look, if something is not being used, you don't need to put it out there. You can always add it when the customer subscribes. So I think this blends well with the new trends about sustainability. Just sharing a couple of words in terms of the building blocks. When you look about LCM, there are essentially two big components. You have the cloud aspect of things where you need the App Store, or in this particular picture, the repository. Here we are using the Broadband forum conventions. That's why you don't see the word apps or packages. You see deployment units, but what that really means is just a set of applications or software modules that you can download and push them to the device. And of course, you need an orchestrator to exercise these things. To push these things, to monitor these things, and we've also seen some examples from ComScope and SoftAtHome, but there are more things out there. On the CPE side of things, you need a protocol adapter. Even though you keep hearing a lot, USB and so on, the reality is we are trying to be as inclusive as we can. We are trying to work with different communities, and we also trying to adapt to different infrastructures, and that's why we are trying to keep things open so that one might use TR69, somebody might use USB, somebody might use WebPA instead, and that's really that mindset that we are trying to follow. Still on the CP side, you need an LCM agent to manage the different execution environments, the different containers, if you prefer to call it this way, which will in turn run the execution units that are the applications, something that you can start and stop. You will also have other things like configuration logs and files that you can also do other actions like backupping, restoring, or maybe getting rid of the application, but not really about these other things. Moving on to the activities, I mean, there has been a lot of work in the past years about defining requirements, defining architecture strategy, but reality is there have been also much code to be shared. SoftAtHome has played a very important role in this aspect. We had roughly 7 deliveries. This has started, the first one came in June 2021, and 1 year later we had the 7 release coming in. So that's really a lot of ongoing effort. Looking at the scope in LCM, I mean, of course, there are more things ongoing, but just to try to keep things short and simple, with 85 out of there's around 200 requirements, business requirements that have been defined. Roughly 85 have been implemented, 15 are partial, and we have some ongoing effort in terms of standardizing the data models, because there were some gaps in the device.software modules, and we are working with BBF to extend them. So as soon as they are accepted, they will also be implemented accordingly. In terms of software stacks, we've seen multiple demos in prpl. ComScope has also demonstrated some demos running in the RDK aspect. And the reason why we are showing this ongoing is because we don't want to just have demos. We actually want to have something that can be used and can be shared, and that's the part which we are working, and Dave Chapman will talk about that. There is one more important aspect here, which are the container technologies. Again, we are trying to be inclusive. We are not trying to push specific technologies. LXE has been implemented and it's running, but we understand as well that OCI compliant images and CRAN is also valuable, so we intend to support both, and this is something that we have on the horizon. Now, handing over to Chris Gray, would you please do us the demo?
The demo consists of a scary movie. So yes, this is it. Very hastily drawn up over the weekend. So what I'm going to basically do is to show the basic operations which we've already illustrated in the presentations we did for Purple Working Group. This is a basic picture of the basic elements there. You have the idea of an execution environment, which is basically a place that containers live in. And you may have different kinds of them, but we start from this point. And now we are going to install the DU. So first, my virtual Renault de la Place will illustrate that all we have is one execution environment, and there's nothing in it. So now we're going to install something. It's a brilliant animation, move over Pixar. And you can see that an OCI image is actually not just one blob, one thing, but it consists of a configuration and one or more file system layers. So they are installed, and that creates a runnable container, which we call an execution unit. Here again is the illustration of that happening. And I think my virtual Renault will scroll back to show you the deployment unit again. By the way, if there's anyone from BBF watching, this is the thing. This is the same demo that you saw in the summer, so it has the same errors which we are now fixing. Then for an update, first you stop the EU, you install, I'm pointing in the wrong direction, you install another one on top of it. The old stuff becomes redundant and will be garbage collected, and then you can start it off again. And here again we see the live shots from when we demonstrated this in the summer for the working group. And finally, to uninstall it, you stop it and basically delete a load of stuff, and in the end, everything will be garbage collected. Let's see that one happen. So there you can see you have a deployment unit in there, and then Renault will type uninstall, or he will copy and paste uninstall, and it will go away. You'll see state changes as stuff go from active, and then to idle, uninstall to uninstalling. There's an event comes out, which is how the backend knows that there's been a change of state. And the other thing we want to talk about is that we're able to create a new execution environment at runtime. So for example, if we want to create one which has constraints on the memory or the CPU usage, we made a command, add execution environment, and you can give it allocated disk space, CPU, that it, whether it should be a child of another environment or not. And having created it, you can also modify the constraints. So you can say, okay, I want this execution environment to have less CPU power or whatever. And finally, of course, you can even remove an execution environment. I should really have rehearsed this thing. So away it goes, and as we'll see in the demonstration, because there was an execution unit already installed in that execution environment, that is going to be stopped and basically killed before we clean up the rest of the stuff. And at the end, we will be left with where we came in, which is one empty execution environment and nothing installed. I obviously thought I was going to say more here, but you can see all the state transitions. That's why I slowed that down a bit. Yeah. So thank you for your time, if you're interested. I'll now hand over to Dave for his demo.
Thanks, Chris. Thanks, João. Just to say, I'm Dave Chapman, Solution Architect, Consult.red. So I'm just going to do a little bit of talk about what we've been doing to bring prpl LCM to RDK. So I'll try and get through these slides quickly before another British Prime Minister resigns. How many days was it? 45? That one, João. Okay, so just the thing to draw from this slide is there's a lot of green ticks to just basically say that a lot's been done. What we're talking about here is porting of prpl LCM onto RDK-B, what we're calling phase 1. So in the architectural diagram you'll see there's the collection of only pronounceable to Chris components. I'll give it a go. Just to draw out some of the components there, this is the detail of what LCM looks like. So there is Timingilla. Essentially, that's the data model providing component. Ultimately, that provides the data model that you've just seen being exercised on UBus there. Behind that, there's a component called Relay. That's responsible for pulling down the OCI images from the OCI image repository, the deployment units that João talks about. And there's the container runtime manager that's called Stulu, and that has LXC behind it. The reason for bringing these things out here is that one of the main jobs of bringing this to RDK-B is just the build system work that needs to be done for all of those components. It's not particularly glamorous work, but they all need their own recipes. They all need patches applied and the like, and we've been working very closely with CommScope on putting that together, and obviously you can see the results of that on CommScope's demo, where they're obviously showing this stack running on RDK-B and on prpl, obviously, in the same way. So the key thing to talk about phase 1 is it's bringing the whole of the stack, including UBus, to RDK-B RDK-B, and then the integration with the OB USB agent, again, over UBus. So all of this is done now. I'll show you references to pages on Confluence where you can jump to, go and get all the code, get all the supporting documentation. All of this that we'll show can be reproduced now for publicly available code and from documentation to drive the demos. So that's done, but in the style of Who Wants to Be a Millionaire, we don't want to give you that. Going on to phase 2, the key part that needs to be done now, and this is work that's ongoing, is rather than bringing over UBus, which is obviously system bus technology that's used in OpenWRT and prpl OS, to align better with RDK architecture, we want to expose the data model over RBus, which is the system bus of choice in the RDK-B space. So to do that, we need to write an RBus backend for AmbiRx, which is the software layer upon which prpl LCM sits and inside which there is a bus abstraction. So currently undergoing, and you can see the work in progress and how functional it already is by going to see the Global Logic demo over there of the RBus backend. That's ongoing. You can see the dashboard there from Jira. That was probably from a week ago, so there's been a bit more progress already on that. We've also done an integration with OBUSP-A to RBus for the part of the data model that relates to LCM. That's done already. So essentially, once the RBus backend is complete, then we'll have a fully functional LCM on the system bus of choice on RDK. And this is what João was talking to when he was saying, obviously, we don't just want proof of concepts. We want, architecturally to be properly aligned and to be ready for productization. So just to reiterate then, work that is ongoing. Obviously, RBus backend for the MXB. We then need to do sort of the end-to-end platform integrations to show them running on our platforms of choice. So for everything that you've seen in phase 1, we already have running on Raspberry Pi, RDK-B, 22Q1, Q2. We also put the work in to make sure that it would all run in a PC environment. So you can run the whole of prpl LCM with the USB integration all on a Linux PC and do the development there. It's also kind of baby steps potentially towards SDK, or at least some of the tooling that you'd want for application developers. And then obviously there's potentially other ports, the CompScope and other platforms going forward as well. There's a bit of review to do on the bit-baked recipes, the layer structure that needs to be discussed and decided where it will always going to live, but we'll follow the prpl mesh approach, I would expect. Beyond that, and this isn't just limited to RDK-B porting, it relates obviously to prpl OS as well. There's potentially as João pointed out, the OCI runtime support for C-Run. We've actually gone and done a lot of that already, so we'll make that available as soon as we can. It's kind of working, but there are a few issues with it we need to iron out, but we'll hopefully release that sometime soon. We're also looking at potentially other models of delivering the applications themselves, like OCI bundles. So just to reiterate again, if you follow these links, you will eventually get to places where you can get all the code, you can get all the documentation, all the architectural documentation, how to drive any of the demo videos that you can see on that page. So that's obviously a key thing, is that we just want to make sure that everything we show, people can go away and reproduce entirely from the ground up, use the source, Luke, as they say. So that's essentially it for me. Anything you want to finish up with, João? We do have a demo video on the Raspberry Pi, but I don't think it'll add a lot more to what Chris has already showed. If you go to those pages, you'll be able to see a lot of demo videos of all those parts of the development on the PC, on the Raspberry Pi, and others. So thank you. Yeah, yeah. Okay. Is there any audio? I'm not going to talk to it like Chris did. I do my best.
I think I have audio.
Can you have audio? Because then
And also subscribe to events from them.
okay.
Next, I'll run this command to start the OB USPA service to be able to connect to it from EcoControl.
So this is just
I'll
talk
refresh
over. This is
EcoControl to show that the device is now online.
this is Raspberry
and then
Pi
run
RDK-B
some
with
commands
EcoControl.
to demonstrate the prpl LCM. So first I'll get the device software modules to show that there's no deployment units installed or execution units. Next I'll run device.softwaremodules.install.du with the following arguments to install a new deployment unit. You can see from the events that a new deployment unit is being installed. And now I can get the deployment unit and the execution unit to show that they've been installed. So you can see there's a deployment unit and an execution unit, and the execution unit is currently running. I can also show this from the LXC side to show that there's a container running, and I can attach to that container to show that it is running Alpine version 3.16.2. Next I can run the set requested state on the execution unit and add the argument requested state to set it to idle. If I run that, I can then get the execution unit again to show that it's now idle, and from an LXC side I can show that it's been stopped. Finally, I can run deployment unit 1.uninstall without any arguments to uninstall the deployment unit, and can verify that. By showing that there are no deployment units, and also on the LXC side to show that there's no containers installed. This is a demo showing the prpl LCM running on RDK-B being driven via USB through EcoControl. First I'll run the script to start the different prpl.
Can we stop? Okay, thanks for that. Okay, so I mean, to wrap up, I don't have much more to add. I really believe that actions speak louder than words, and I think that's exactly what we did today. We had a demo from Chris showcasing LCM running in prpl, and we also had Dave and Consult.red showing us these works also taking place in the RDK-B software stack. So as you can see, as we've been witnessing from other people speaking, this is not about a battle of RDK versus prpl. This is more about being inclusive, being listening to each other's needs, not forcing specific directions, but trying to design solutions that can adapt to our different realities. And then the reality is that we can reach way farther by working together, and that's real all. Thank you very much for coming, and if you have questions, you'll find us around.